All right, hello everyone. Time to get started on our statistical process control work. So in this video, we're going to talk about precision, accuracy, and our capability indices, CP and CPK. All right, so let's get started. Let's talk about precision and accuracy. So we need to understand this for a little baseline knowledge here. So let's say that we're going to throw darts. Our target is going to be the bullseye. We're not playing cricket. We're just throwing at the center of the dartboard today, okay? So we throw some darts. What happens? We get this result. Would you say you're precise, accurate? Neither. The correct answer is actually accurate. So accuracy is when the points average around the target. So if we had to draw an average of where we threw, we would land pretty much dead center. So that is highly accurate. It's not precise though. This is precise. Precision is when we get the same result or a very similar result every time. So in this instance, we would be able to easily adjust. We would aim at the 2 this time rather than the bullseye, and we should land on center. So precision is good for making adjustments. This is both, right? So this is both precision and accuracy. So we're averaging around the target that we want to hit, and we're getting a very consistent result. And then this is neither, right? We're neither precise nor accurate. This is not a good situation. All right, now let's apply this a little bit to statistics. So we have our normal distribution curve. Here is our bullseye right here. And we are trying to hit here. Would you say that this is a precise or accurate distribution? Correct answer would be precision. So this is, we have a very tight distribution here. We have a low standard deviation, but we're not really near our target. Next one. This one is neither precise nor accurate. We're not centered around our target. And we've got a pretty wide distribution, a high standard deviation. This one, hopefully by now you're getting good at these, right? So with this one, we are averaging around our target, but we don't have a high level of precision here. And then the last one, this is both, right? So we have a small standard deviation, a tight distribution, and we're centered around our target. All right, a couple more things here. Accuracy, a low accuracy causes a large difference between the result and what we believe to be the true value. So this is you want a high accuracy, right? Because you want a small difference between what you're aiming for and what you're getting, right? Another term you might run into is bias. This is the difference between the average of your measurements and your target or reference value. This often comes into play when you talk about measuring systems. And a little more on precision. Precise groups are grouped tightly together. They have a low standard deviation of measurements, and two kind of subcategories of precision: repeatability and reproducibility. Repeatability is the same person gets the same result measuring with the same measuring device, measuring the same object. So everything is the same. We repeat the exact same thing, and we get the exact same result. If we don't, we have a low amount of repeatability. Reproducibility is different operators using the same measuring device, measuring the same part. So this is, I use a ruler to measure the length of something, and then I give you the exact same ruler, the exact same thing to measure, and you get the same result. These are both used when we do a gauge R&R. That we won't be doing that in this course, but you might run into that in the future. A gauge R&R is a repeatability and reproducibility exercise. All right, now that we understand some terms, we're going to move on to CP and CPK. So this is the process capability and process capability index. So we'll talk a little bit about these. So if you remember, we have our normal distribution curve, right? You have your 68, 95, 99 rule, right? This will come into play a little bit more here. So the upper and lower control limits are plus or minus 3 standard deviations. That's called a UCL and an LCL. What we're going to talk about today is a USL and LSL. So how to remember the difference. So the UCL, those are your control limits. They are controlled by the process. Your USL, LSL, those are spec limits. Your spec limits are specified by the customer. That's your easiest way to remember that. All right, now we're going to get into the formula. So our formula for CPK is the minimum of these two formulas. So they look complex at first, but they actually aren't that bad. So you have your upper spec limit, which will always be given to you, right? That's again, spec limit is specified by the customer, minus your X bar, which is your mean, right? Your sample mean, divided by 3 standard deviations, sigmas, right? 3 sigmas, 3 standard deviations. So we calculate that 200 minus 150 divided by 3 times 15. All right, so that gives us 50 divided by 45. And then on this side, we have X bar minus LSL, again, divided by 3 sigmas. And if, again, we get 50 divided by 45. So in this, both sides of this are 1.11. And that happens because our mean is centered between our upper and lower spec limits. So the correct answer for this one is 1.11. You would take the minimum, or in this case, they're the same. Now let's use these same numbers and calculate CP. So we have upper and lower spec limits, right? You just subtract lower from upper and then divide by 6 sigmas. So now we have 100 divided by 6 times 15. Again, we get 1.11. So when we have the exact, the only way to get the exact same result with CP and CPK is if the mean is dead centered, right? That's the only time that happens. All right, now let's change just a little bit. Let's change the mean. So the mean is now 125. So we'll work through this again. 200 minus 125, right? Upper spec limit minus our mean divided by 3 times our standard deviation. Then we have mean minus lower spec limit divided by 3 times our standard deviation. There you go. And our CPK is 0.55. So then we'll go over to the CP side. So USL minus LSL, 200 minus 100, times 6 times 15. Now you'll see here, we're going to get the same result, 1.11, even though we changed the mean, right? Because the CP does not use the mean. That's why CP is not as good of a measure. All right, so let's compare these. So in this example, right, so this is our first problem, we get a CP and a CPK of 1.11 because our mean is dead center between these. In this example, we have shifted our mean. You can see that we're actually going to have some of our distribution fall outside of our lower spec limit, right? So that's what CPK does a better job of. CPK does a better job of telling us when something is going wrong, right? And that's really what this is. So we'll go to the next slide here. So what does this all mean? So a CPK or CP are used to monitor a process. So you will run some parts, you will measure them, you'll measure customer wait times. There's a lot of different things you can measure, and you'll come up with a CPK, and it simplifies all of that. So your goal is to have 2 or higher. Really, the acceptable level, depending on who you talk to, but the acceptable level is right around 1.33, right? This is where we're aiming for our CPK. So if we're above 1.33, we're pretty happy. If we're at 2, we're ecstatic. If we're below 1, we're really concerned, because when you look at process yield, right? So if you get below 1, that means you're throwing away 7% of all of your product, right? So only 93% is within specifications. You might hear the term defects per million opportunities or parts per million. So Six Sigma level quality means for every million parts you produce, 3.4 are bad, right? So this is that's the standard of quality that when you hear about Six Sigma that they're referring to, right? So we're always trying to push our CP and CPK higher, and this is one easy way of measuring it. All right, so it's kind of a loose term you don't understand other than it should be 1.3. Our goal is 2. So what does that mean? Well, if you want a way to visualize this for you visual learners, a CP or CPK of 2 means that you can fit 2 distributions inside of the in between the upper and lower spec limit. That's the way to kind of visualize that. All right, now a question for you. So think about what we've learned so far. So which one has a higher CPK and which one has a higher standard deviation, or are they the same? This is where I guess you pause the video if you want. So the higher CPK has a lower standard deviation, and those are the answers. So the green has a wider distribution, so it's going to have a lower CPK. The red is going to have a tighter distribution, so it's going to have a higher CPK. The way to improve your CP or CPK, well, the way to improve your CPK is to either center the results around the center the average around the center of the upper and lower spec limit, or reduce your standard deviation, reduce the variance in your process. The only way to improve CP is simply to reduce variation. But again, I recommend CPK, not CP. All right. A couple more questions for you guys. So think about which one is which. So think about first which one has the higher and lower standard deviation. So look at the distribution. So some of them we can kind of knock out here. So we see that this has the smallest standard deviation. So that would be the tightest distribution. And then this mean is higher, which is closer to the upper spec limit. So hopefully you got these as the answers. And then for the next one, this is a little bit trickier. So your CP and CPK can only be the same if the mean is centered in the upper and lower spec limits. Okay? And CP, with a tighter distribution, the CP will be higher, right? When it comes down to results, which one is actually better? This is the better result, right? It has the higher CPK, but it's still not a very good result. We have a lot of product falling outside of our lower spec limits. All right, that's all for this video. Things you're going to want to know, that the terms we've gone over, you're going to want to commit the CP and CPK formulas to your notes. These two formulas here you'll want in your notes. There will be some quiz questions based around that. That's all I've got for this video. We'll get on to the next one.